Ground-based telescopes have given us an enhanced view of the stars, capturing more light than our eyes can perceive. Throughout history, numerous instruments have been created to study space, but none have come close to the scientific leap achieved by the James Webb Space Telescope. This telescope was literally designed to embark on a journey to the origin of the universe, and that is exactly what it has achieved. As far as exoplanets are concerned, we now have the official image of the City of Lights on Proxima b, a historic milestone that changes everything. In addition, 18 separate images are expected to be obtained, one for each mirror. But that's not all. Recently, the James Webb Telescope has captured the clearest image of another exoplanet. Join us as we explore this incredible discovery made by the James Webb Space Telescope and what it could mean for our future. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel, be sure to like this video, and turn on the notification bell. Thanks to the James Webb, scientists will be able to look back in time to a time when the universe was only 200 million years old. The information we can obtain from this invention will probably allow us to go back in time and better understand the evolution of the universe. This is not all. This telescope is also capable of capturing images of some of the first galaxies that formed, allowing us to witness the first stars in the universe twinkling in the dark void of space. But how does the GWST achieve its amazing capabilities? Well, it has a huge 21-foot diameter mirror that captures and reflects light back to the spacecraft's instruments. Speaking of instruments, the James Webb has 4 of them, each designed to capture different types of light and provide a unique view of the universe. First, there is a near-infrared camera, which is the main camera and is directed to capture stunning images of distant galaxies, nebulae, and other cosmic wonders. We also have the near-infrared spectrograph, which breaks down light into its components to reveal more information about the observed objects. The near-infrared instrument is specifically designed to capture infrared light and study exoplanets in the early universe, and even our own solar system. There's nothing that escapes its observing capabilities. Finally, this wonderful telescope features the near-infrared fine targeting sensor and a spectrograph, which is used for precise pointing and is very sensitive to near-infrared light, leaving no detail undiscovered. Now, you might wonder why NASA chose infrared for use with the James Webb Telescope, especially when there are so many types of light available. The choice of infrared is due to several reasons. First, infrared allows penetration through cosmic dust and gas that would block visible light. In addition, infrared is ideal for studying cool objects, such as stars in formation, exoplanets, and distant galaxies. By using the infrared, the GWST can reveal details and features that would otherwise be difficult to detect using other ranges of light. The James Webb Telescope made history by capturing its first direct image of an exoplanet. This exoplanet, named AHB 65426b, was discovered in 2017 and is located at a distance 100 times greater from its host star compared to Earth. To observe this colossal gas giant, scientists used the James Webb Telescope and applied several filters. The images obtained were combined to create the resulting image of the exoplanet, an exciting achievement for astronomers. According to Sasha Hinkie, an astronomer at the University of Exeter in the United Kingdom and leader of these observations, this moment is not only transformative for the Webb Telescope, but also for astronomy in general. What makes this exoplanet special is its size, approximately 12 times that of Jupiter, and the great distance separating it from its host star. These features made it more feasible to capture a direct image using the Webb Telescope. However, direct imaging of exoplanets is not just about obtaining visually stunning images. It is about understanding the origins of exoplanets and exploring the possibility of life beyond our own solar system. These images could provide clues about how planets form and what kind of atmospheres they possess. This, in turn, could lead to the discovery of exoplanets with habitable conditions, a goal pursued for decades. While research so far has shown that there is little hope of finding a habitable planet, the fact that the James Webb Telescope has the ability to zoom in on planets means that if a habitable exoplanet exists, it will be the James Webb Telescope that will be the first one to discover it. If all of the above was impressive, what happened next exceeded all expectations. Scientists announced that the James Webb Telescope has successfully observed the oldest galaxies known to mankind. These galaxies formed when the universe was just a baby, representing just 2% of its current age. The amazing thing is that these 4 galaxies are the most distant ever observed, located at a staggering 13.4 billion light-years away from us. Let's reflect that for a moment. The light emitted by these galaxies took 13.4 billion years to reach our telescopes. That is an almost unimaginable distance. Despite this, the James Webb Telescope has managed to observe them and capture images of what they looked like more than 13 billion years ago. The process of observing these ancient galaxies was not an easy task. First, scientists had to identify them, which is not easy considering how far they are. However, thanks to the infrared capabilities of the Webb telescope, it was able to pick up the faintest signals, and, as a result, researchers will be able to identify these 4 galaxies. But the identification of the galaxies was just only the beginning. To confirm the true age of these galaxies, the scientific team had to analyze the data collected by the James Webb Telescope's near-infrared spectrograph and measure the redshift of these galaxies. As mentioned above, the redshift is a measure of how much the wavelengths of light emitted by an object have lengthened as the universe expands. The higher the redshift, the farther away the object is from us and the older it is. The redshift of these galaxies was measured to be 13.2, the highest ever recorded, indicating that they are the oldest galaxies known. It is difficult to overstate the importance of this discovery. These galaxies formed even before the first stars originated in our own galaxy. The Webb telescope has managed to capture images of these galaxies, giving us a glimpse into the earliest days of the universe. This kind of discovery has the potential to transform our understanding of the cosmos and challenge our current conceptions. In addition to this exciting achievement, there has been recent interest among researchers in the possibility of the Webb telescope capturing the sharpest images of city lights, a projection of human activity on Earth. Although this may seem like a difficult challenge, the conditions for doing so are favorable. For example, the closest star to the Sun, Proxima Centauri, is a red dwarf located at a distance of 4.25 light-years. This is where astronomers enjoy the planet Proxima b, which lies in the habitable zone of its star, and is believed to be in a tidal lock configuration, with one side permanently illuminated by day and the other side in darkness. If there's a technological civilization on Proxima b, they may have covered the day side of the planet with photovoltaic cells to generate electricity and provide illumination, which would also heat the night side. This is where the James Webb Space Telescope comes into play. In a recent scientific paper, researchers demonstrated that the James Webb Telescope could detect city lights on the permanent night side of Proxima b, even if the artificial lighting is as dim as what we used on the night side of Earth. The Webb telescope would be able to detect it as long as it was restricted to a frequency band 1,000 times narrower than starlight. In addition, NASA's proposed future space telescopes such as ultraviolet and optical infrared will be even more sensitive to fainter levels of artificial illumination on Proxima b side. The idea that there can be lights on the planet more than 4 light-years away is amazing, and it is a reminder that there is still so much to discover in the universe. With telescopes like the James Webb, we're one step closer to understanding everything that goes on in our own solar system and distant galaxies. That concludes our video for today. We'd love to hear your thoughts in the comments on whether you think the James Webb Telescope is the answer to all scientific questions or if we need more advanced telescopes. If you enjoyed this video, don't forget to give us a thumbs up and we will see you in the next one.